Okay, we just finished up talking about passive transport. Passive transport is the movement of particles from high concentration to low concentration. No energy is needed. Examples are diffusion, facilitated diffusion, and osmosis. Now we're going to talk about active transport. Active transport requires energy. We're going against the concentration gradient. In other words, we're going from low concentration to high concentration, which is exactly why energy has to be applied. Protein channels, protein tunnels, protein carriers, whatever you like calling them, also function in active transport. So they function in facilitated diffusion, which is a passive transport system. They're also going to function in this active transport system. And in order for this to work, the mitochondria have to be near these channels. If you remember, mitochondria are providing energy for the cell, so it's going to be providing energy to the channels so that these particles can be pumped in the correct direction. The only type of active transport system you're going to have to know is something called the sodium-potassium pump, and it's going to be happening in your muscles. Sodium is forced out of the cell. Potassium is forced into the cell. They're going to be changing places. Movement in both cases is against the current concentration gradient, so we're going from low concentration to high concentration. This happens in the process of muscles contracting and relaxing, which if you take anatomy phys, you're going to learn a lot more about this. Okay, but I'm going to draw a picture for you dealing with sodium-potassium pump. So we learned earlier that the cell membrane is made up of 2 layers. So I have to draw my 2 layers. My heads, my tails for each of my lipids. So I have 3 lipids there. I'm going to have 3 lipids. You know that the heads and the tails, the heads all face out, away from each other. The tails are touching each other. That way the tails don't have to be in water because they're non-polar. They don't like water. The heads do like water. So by facing away from each other, they're actually sitting in water. There's a protein channel. And I'm going to draw some mitochondria hanging out here. Okay. And what this says is the sodium is being forced out of the cell and the potassium is being forced into the cell. So let's say this is in and this direction is out. Okay, so outside we have sodium sitting here. We have lots of sodiums. Didn't leave a whole lot of room to draw my sodiums. Okay. So the sodium is being forced out of the cell. So it's going in this direction. And we don't have that many sodiums in here. Maybe just a couple of them. Okay. And the potassium is being forced into the cell. And I already have lots of them inside the cell. I'm going to add some more lipids over here so it makes sense. Let's have some more K's over here. Okay, as you can see, there's all kinds of potassiums in the cell. So you wouldn't think that they would normally want more in there, but at this point, because of things happening with your muscles, you need more potassium in your cell. So the sodium is being forced out. Potassium is being forced in. And it's those mitochondria that are hanging out there, supplying the energy to the protein channels so that the sodium can be forced out and the potassium being forced in. And if you don't know, I use the chemical symbols for sodium and potassium here. That's why you see NAs and you see Ks. Again, my drawing is not the best because I didn't have a whole lot of room. I made my cell membrane a little large. So if you'd want me to, I could redraw this in class. Just ask.